In this video, you will learn how to use the table to evaluate a function at various points. The table allows you to input values for x, and you will get back the corresponding values for y. You will also learn how to customize the table using the Table Set option. First, let's learn how to set up the table using the Table Set button. We will begin with example number 1. Let's say we wanted to plot 4 points for the linear function y equals 2x plus 1. So we want to input this function into the calculator. We do that by selecting the y equal and then 2x plus 1. So let's get out of this by hitting second function and then quit. Now we're going to press second function, and then here you can see TBL-SET, which means table set. So we'll select that button. Alright, your screen may or may not have these settings, but I will cover each setting in detail. But first, let's set up the table the way you will be using it most of the time. Okay, and the way you're going to be using this most of the time is you want the independent variable, those are the x values, to be on ask. What that's telling the calculator is that you can choose any x value that you want. So I use the cursor to bring it down, moved it over to ask, and then I'm going to select it by pressing enter. Now the dependent variable are the y values, so you want that on auto. So you're going to be asked to input your own values of x, and then it's going to automatically return the values for y based upon the functions that you have inputted in this screen. Okay, so you're going to be inputting values for x right here, and then it's going to give you the values for y1 back. Okay, so let's go back into the table set. So that's second function and then table set. So don't worry about this right now, or this. I will get to these settings a little bit later. So almost all the time you're going to be using these settings, the independent on ask and the dependent on auto. So let's get out of this, second function, and then quit. Okay, so let's apply this to the function that we inputted earlier. So we're going to go to second function and then table. So here's table, so we hit that button there. So remember, here are the independent variables and then the dependent variables. So remember, we're going to choose values for x. Alright? In this particular case, we're going to use -2, 0, 1, and 3. So what we do is we input one of these at a time and then press enter. So the first one is -2. Then we press enter. Then we'll press 0 and then enter. And then 1 and then enter. And then 3 and then enter. So you can see each time that we inputted a value for x, it gave us back the corresponding y value. So when you put in -2, y was -3. When you put in 0, y was 1. When you put in 1, y was 3, and when you put in 3, y was 7. And that makes sense because the function is 2x plus 1, so let's just check that out. When you put in 0 for x, you should get 1 back. When you put in 1 for x, 2 times 1 is 2, plus 1 is 3. So you can see it's giving you back these values for y. Alright? So now you have 4 ordered pairs that you can plot, and these are shown to the right. You can graph the function, but it will not show the points from the table. So if we go second function and quit out of this, and then we go ahead and hit graph, okay, it graphs the linear function, but it's not showing you those points that you actually put in your table. Okay, the calculator, remember, automatically picks all of these points and then just draws a line connecting all those points together. Okay. So if you wanted to, you can go back and change the values you entered, add more, or delete them. So let's see how we can do that. So let's go back to the table mode. So second function, and then we hit the graph button because it controls the blue word table there. So we hit that key. All right. Let's just say that we wanted to add another number here, like -5, and then we hit enter. Now if we wanted to change a value, we can scroll up to any value that we'd want to change. So let's say we want to go to the value of 1, and instead of being 1, let's say we wanted that to be a 10. So we would enter 10 right over that highlighted 1, and then we select enter. If you wanted to delete a value, you simply go to the value you want to delete. So let's say we want to delete -2, and then we go ahead and hit the delete key. Okay, so it gets rid of that. So let's input a few more values, and I want to show you something that happens. So let's put in -4, enter, 6, enter, 7, enter. Okay, now we've run out of space here on the screen, so if you try to scroll down, nothing happens. So you're only allowed to have 1, 2, 3, 4, 5, 6, 7 values on the screen at one time. Okay? So this is where you'd want to overwrite any values that you don't want to see anymore. So let's say I want to go up to the beginning and I want to put a new value in. I just would have to overwrite it here and put like 3 and then enter, and then I could put in -5 and then enter, and it'll just keep overwriting these. So the main thing is just to realize you can only have 7 values at one time. Alright, so let's go ahead and get out of this. So second function and then quit. Alright, now I want to make a note here, and using the table will be very useful when graphing a function that cannot be seen in the standard window. So remember when we graphed on the previous videos, we were always seeing the function in the standard window was coming up right there. Well, there'll be times when you hit graph and you won't see anything. So this is where the table function will come in handy, and this is covered in the video called Finding a Good Window. Alright, so let's clear this out of memory. So we hit clear, and let's get out of this, quit, and we will now go to example number 2. So let's say we want to plot 7 points for the function y equals log of x. So let's first input that into the calculator. So y equals the log of x. Alright. Then we can go ahead and quit out of this screen. So second function, quit. Alright. The domain for the log of x is that x must be greater than 0, so we will choose 7 values for x that are greater than 0. You can pick any values, but let's choose these values: 0.1, 1, 10, 50, 100, 700, and 1000. Okay? So let's go ahead and go to the table button, so second function and then table. Alright, let's delete all of these values out of here. One thing I want you to notice here, you can see in the Y column it says error, error, and error in these 3 places. Well, the reason why we're getting an error here is because look at, there's a -5, repeated -5, and then a -4. Remember that the domain for the log of x says we must have values greater than 0. So that's why we're getting errors here, because obviously these values are not greater than 0. Okay, so let's go ahead and delete all of these values out. So you just hit the delete key for each one. Now let's input the points that we've chosen. So 0.1, then enter. 1, then enter, 10, enter, 50, enter, 100, enter, 700, enter, and then finally 1000, and then enter. So again, we picked values of x, and we're getting the corresponding values of y back. So these are the ordered pairs: 0.1 minus 1, 1, 0, 10, 1, 50, 1.699, and so on. Now, like I mentioned before, if you go ahead and try to graph this, you do not see the individual points that we chose in the table. Okay? Now let's look at another setting in the table that is not commonly used, but it can be useful if you are trying to find some patterns of how the x values are affecting the y values of the function without inputting each x value individually. So let's go back to the table set. So that's second function, remember right here. So we press this key, the window key. Alright. Now what we're going to do is we're going to change the independent variable on auto. So it's automatically going to choose the values of x for you. So let's move the cursor down, highlight auto, and you would select it by pressing enter. Okay? Now what this does here, it says where do you want the first value of the table to start. Now here it says 0. Okay, now remember that for this particular function, for the log of x, the domain are values of x greater than 0. So we can start at greater than 0, or we could start it at 0. What will happen is that we're going to get an error when it starts out at 0, but that's okay. Alright? This says delta table. The little triangle means delta. So delta table equal 1 means that the spacing between each increment will be 1. So if you start at 0, you're going to go 0, 1, 2, 3, 4, and so on. If you set the delta table equal to 5 and you start at 0, then the spacing between each increment will be 5. So it will be 5, 10, 15, 20, and so on. So in this particular case, let's go ahead and choose 10 as the increment. So we will move the cursor up and we'll replace that with a 10. Okay? So the table starting at 0, there's going to be increments of 10 between each value, and the calculator's automatically going to put in the x values, and it will automatically be giving you back the y values. So let's get out of this second function and quit. Now if we go to the table, second function and table right here, so we hit the graph button, you can see we're starting at 0, and then the increment is 10. Alright, so 0, 10, 10 to 20, 20 to 30, 30 to 40, 40 to 50, 50 to 60. And remember, the reason why we have an error here is because, remember, for the log, the values of x must be greater than 0. Okay? And like I said here, this is a good way to check out if there are some patterns that you can see. So you can see that increments of 10, the values don't really change too significantly. What's nice about this feature is that you can scroll down and you will be getting more values. See, so it keeps scrolling. It still only shows 7 values at a time, but you can keep scrolling down because the calculator is just putting in increments of 10 each time. So one thing you can say about the log is that the values really don't increase too significantly as you're moving further out on the x-axis. So you can keep going down and checking the patterns. Alright, let's check at 300. So at 300, let's keep moving this up a little bit. So from 300 to 360, you can see that you're only going from 2.5, if we round off, to 2.6. So if you're going 60 units, you're only increasing by 1/10. Okay, so that would be one pattern that you could recognize here. All right. So this concludes the use of the table and table set for the purpose of evaluating functions.